Hello everyone. Thanks for joining today's webinar. Let's wait a couple of minutes and then we will start. Okay, let's go. So thanks again for joining us. Today's webinar is about parallel processing with Robomotion. We will cover lots of topics tonight. We prepared many example flows for you. After the webinar, we will also share the slides and the example flows. So today's agenda is we will cover the basics of branching. This is similar to threads in programming languages that we call branches because we design a visual flow and you see the branches visually. So there are two kinds of branches in Robomotion: static branches, where you design the branches by hand manually, and also dynamic branches that we call you can create a dynamic branch given by a variable that you can create branches on demand. And we will cover the topics about single robots and multiple robots usage, why and when to use multiple robots. Do you need to use multiple robots, or single robots is enough, or where is it enough? We will talk about queues to cover synchronization between multiple robots. We will cover SQLite and SQL databases for synchronization, and also serving APIs and some examples using APIs. So let's continue. So a flow branch in Robomotion is just a sequence of execution of nodes you connect one after another. That's what we call a branch. Robomotion is a little different. It's an RPA product. In the market, you see most of the RPA products provides you a one sequence of automation. You can open a browser, go to a link, and click something and download something. This is just one sequence. But with Robomotion, you can run multiple branches of sequences in just one flow. This is very powerful. Most of the time, your projects would need multiple robots. You need to add another robot and another robot. But if this is a one project, one flow, you can use multiple branches. So you can just use one robot in your projects and do many things. Only the memory and CPU resources on your machine is your limit, because when you run multiple branches, if actually you are using a Chrome automation and Chrome browser, Chrome consumes lots of memory. It is about maybe 500 megabytes to 1 gigabytes of memory. So you would need lots of them. So let's jump into examples. Here we prepared some examples for this webinar. This is a simple browser automation. Actually, this is what we call a branch. This is one sequence of automation. Here, when we press play and when we start our robot, this flow will start, and this subflow opens a browser, goes to a link. This goes to CoinMarketCap and gets the BTC price and shows it in a message box. Let's see how it runs. So this robot is currently running on my machine. Here actually at 1.18, we also updated our application here. Blue still is my robot running here. I have other robots. Also, we will connect and use them. So let's run this. So it opens the browser, goes to CoinMarketCap, and gets this price, and we will see it in a message box here. So this is just one sequence, and this is the simplest example I can show you for browser automation and for you to understand what one sequence means. So let's jump to the other example. This is also interesting. This is actually the same example. This will also show the power of Robomotion. You can serve a web service inside your flows with Robomotion. So here what we do, we copy pasted the previous subflow. That subflow was starting when I pressed run. And now here we put an HTTP in node. This is a special node. This creates a web service inside your flow. The properties are also simple. You select the method you want to use. You select an endpoint. You can select anything here. Here, the get BTC price will be getting by this endpoint, and the IP and port are the bind IP and address here. This example shows you multiple branch. This is the simplest also to show you what multiple branches means. This is one branch you see, and below there is another branch. This actually uses the path parameters, dynamic path parameters here. This is a syntax we added in the latest version. When you use this syntax, you can use this in your flows as a dynamic variable. Here, the create link actually uses the path params coming from the HTTP in node. Token is the given name there, and we create a dynamic link, and here we go to that created link and get the price there and create the response. So HTTP out is, these are the web service nodes. You need an HTTP in node and then HTTP out node. This is for the input, this is for the response. So for the response, you can return the status code, and the body is what you will return. You can set the body in your flow. We can see it here. We return a JSON object. This can be anything actually. You can actually return a string, but we are returning this value, the name of the token, and the price we get. Previous flow was showing this in a message box. And when we look at the get any price branch, that is also similar, but this is dynamic. So let's see how create response is. So we return the name, the given name from the path. Now let's run this and see how it works. Now when I run this, previously we see immediately a Chrome browser started, and we see a message box. Here the flow is not triggered. We have to trigger this flow. We will do that with a curl. So let's call this. It was in localhost 1990 port, and we named the endpoint tokens and Bitcoin, if I remember correctly. Yes, tokens and Bitcoin. Let's run this. When I run curl, you see that it is triggered. The top branch is triggered, and it gets the price and returned it here. We can actually see it beautified with a command line tool called JQ. Let's run the below branch. So this branch takes dynamic token name, so we can write here anything. Let's write Dogecoin, and let's pipe this output to JQ to see it in a colored mode. You see when I run this curl command, it opens the browser and goes to Dogecoin site and gets the price here. and will return it. Here we see it is colored by the JQ command. So we can run another, for example, let's look at the Ethereum price. Again, it is triggered. Also, this can be done multiple times. We can run this. Let's run this and then let's run this for the Bitcoin again. You will see multiple browsers are opening. They are running at the same time and they all return to results to the client. So this is what we call multiple branching. Robomotion is not just a one sequence of automation. You can run tens or hundreds of these branches at the same time. So let's continue. So the topic static and dynamic branching is important. Let's go to that example. The static branching is actually this example we saw in the previous webinar as a teaser, but we didn't have time to explain this webinar. So we will cover it today. So static branching means you add the branches manually. Actually, this flow has 3 worker branches. These are all very simple flows. This is a random sleep. It is a fake process. We will use it for fake process. And at the end, it marks something as done. This is also needed. We will cover this. And all the worker subflows are similar. Some fake processing and some setting a variable, setting to done. And here again, same. So you see when we press play, this flow will start. This is the inject. This is the inject node. We rename it as start. Some users from the community are asking where is the start node. We just rename it to start. It is actually the inject flow. So below you see another inject flow, because we can run the same multiple branches. You can add as many inject nodes as you like. These will be triggered when you press play. And here we have a function node to check if the worker subflows are finished. You have to do this. This is important because if you run this worker flows and, for example, at the end of this, you add a stop, this will end all the flow here immediately. For example, if you have worker node 2, it is working, it is not finished yet. But if you call stop, all the flow will stop and the jobs won't be finished. So to stop in the right time, you need a mechanism. This is the simplest one we use. We can use variables for this. If you have static branches, you can add multiple variables, Boolean variables, and the default values are false here. When you look at the worker subflow, after the fake processing, we set that global variable to true, and then it will just show us a debug that it is finished, it has finished. And this check completion has to be checked more than one time, because you have to check again and again to understand if the flow is finished. So this inject node is also doing that. When you select once for the inject node, it starts immediately, waiting the once delay seconds. This is the default value 0.1, so it starts immediately. But if it is unchecked, it will trigger every 2 seconds, sorry. And here we checked all the global variables with end, and we check this completed value. If this is true, then we understand that all the worker flows are finished. So this is also maybe interesting. Most of the function nodes return a message objects only, but function node can do more. There is a property called here outputs. You can increase the output ports here, as many as you like, and you can write a syntax, write a logic here, check something here, and return from the port you like to return. So this syntax is, this is the array. We return an array if there are multiple outputs exist in a function node. The first message, this is the first port, this is the second port. If it is null, then nothing goes there. If it is the message object, it will output the message object there. This is also interesting concept. You can I don't want to confuse anything, but you can also return from every port if you add message object here. This may come handy in some situations, but here we just want to continue from one of the ports. So here the top port means if it continues from the top port, it means we have finished the job. So let's check there. Yes, here stop, and we will see a debug here. So let's run this. All the worker flows started at the same time. Some of them, they have random sleeps, so some of them finished earlier. And every 2 seconds we checked, and at the end we saw that all of the worker branches are finished, and we can stop the flow. So what you can do with this, for example, you can schedule this flow. Your worker branches may be some scraping task. You may have 1,000 or 10,000 product pages to be scraped. You can divide those pages into these branches, and it will work at the same time in parallel. You can open multiple Chrome browsers here, headless or the default Chrome, and these all will run and finish much faster than a single sequence of automation. So let's continue to the dynamic branches. Example. So here, this is a little complicated, but let's cover this. We currently don't have a mechanism to create multiple branches dynamically. So we use for each node to simulate creating branches, and this is how we do it. For each node to work, it needs an array. You just provide the array in the loop through object, and for every item in the array, you can give a name here, any name you like, and for each iteration, the flow will continue from the top port. So if we have an array and it will continue from here, it will be processed. You need to return to the for each node's beginning, and most of the time you will see this and a stop here. So what it will do is this will run sequentially. The worker will do its job, and it will return to the beginning, and then again, and then again. But what we do here is differently. We again don't stop here. If we do that, we will stop the flow immediately. We just don't use the bottom port. What we do here is, because we can run in parallel, for each item going through the top port, we branch it here and return it here immediately. So this may seem complicated, but it is actually easy. It is just returning immediately. At the same time, it is continuing here. So what it does is it iterates all the items in this array at the same time, and this makes creating the worker branches. So what we have to do here is create an array of objects. The contents are not important. Just we need the number of branches we want to create. The item count has to be number of branches. So for that, we use a variable here, number of branches. This is why we call dynamic branching. If we write 5 here, this flow will create 5 worker branches, and if we change this to 10, it will create 10. So let's see how it does this. So we have a function here, init branches. This is actually, this also may seem complicated, but we find this in Stack Overflow. This is just a way of creating an array of objects. We need just a count of any object. So we create an array of worker1, worker2, worker3 strings. This is a string. This just creates a strings array for us to use for each node to create branches. So after that, we create a DB. So for synchronization of dynamic branches, we use a DB because we can't create the variables here. The branches are not known. You can maybe create some variables here. If you do, then you actually are creating static branches. But we don't know the number of branches in the flow. So we use DB to synchronize these running branches. It is similar idea. When this worker subflow finishes, we go to a check completion subflow, and if all the branches are finished, we then stop, and if not, we go to this still working debug here. So to do that, as I said, we use SQLite. We will cover this synchronization with SQLite, but let's see an example here. So what we do here is, let's check this function. This is just the syntax of SQLite database. We will cover this in later slides. But what we do here is we create a database. An SQLite database is a very simple database. It is just a file with an extension of DB. So it is just a file. You can carry it in anywhere. You don't need to install a software, run a server, but you can use SQL while using SQLite. It is very useful and we use it everywhere. So we create a database file actually, and we connect to that, and we create a table. So our table has just two columns, a worker column and a status column. Let's also see that. What is the name? Let's check that name again. So it is created in workers. Let's change this to webinar 26 Jan. And let's use this, and we will see it in the file browser. Let's go to webinar folder. 26 Jan is correct. So here, let's continue. And then we will create a database file. We will create a table. Let's run this. We will check it after creation. So it starts, it creates 5 branches. It is also running random sleeps. You see still working is always fired, and at the end we will see stop here. Now let's check the database, how it is like. It's a SQLite database. It is just a file, as I said. Let me find it. Yeah, workers DB. Here it is. Let's see what's inside. So this is the DB. Because this is a DB, we can insert as many rows here as we like. You see what how we do the synchronization is by just updating this status field with 1. If it is all ones, then it means it finished. So we created the DB here. We do our work here. This is again a fake process, random sleep, and then we update the status with a SQL insert script, and we update. The worker comes from the name we generated at the beginning here. We generated an array of names, worker1, worker2, worker3. So every iteration has its own name in the subflow, in the message.worker object. And then we update it. And when we see the check completion node, we see get completed select query here. We count the status column as count and we return it. And we compare it with the number of branches. We get the number of branches 5. If the count of status ones is equal to number of branches, then this means this flow has finished. Of course, this is just an happy path. Any of the branches may fail, and maybe they cannot update the status also. So you have to handle all those cases. Maybe with catch, you can just call it finished, or with another status code, maybe, but you need to consider that to understand when to stop the flow. So this is dynamic branching. This is the mechanism we use. Maybe later we will introduce some simpler nodes to create multiple branches. We won't need this. And also we need a mechanism to check this completion. We are thinking of adding a countdown, maybe a node. If a message comes to that node, it will decrease the count, and if it reaches to 0, it will continue, and just a stop connected to that node may be useful. So we will add more mechanisms here, but here currently we do in this way. So let's continue. So single versus multiple robots. This is also an important topic. So as we see in the previous examples, one robot of Robomotion can run multiple branches. So one flow can run one branch on one robot, and also you can run n branches on just one robot. You can also use multiple robots. This is allowed. You can run or install multiple robots in one machine, and also you can install to different machines. You can run the same flow. Maybe that flow has one branch, but you run that flow in multiple robots. That is an option. Or a flow may have n branches, but you want to run also that flow on multiple robots. So these are all options. We managed to run 300 robots on one machine. We are experimenting all the time, but there are cases you need that, and there are cases you don't need that. Let's see when to use multiple robots or just use a single robot. For example, if you have a huge task at hand, we have an example in the next slides. I give this example a lot. For example, you have 10,000 PDF files, and you extract the data from a PDF, and you need to enter that data. You log into a portal and enter that data and submit it into maybe a CRM system or something else. And after finishing that sequence, you need to return to the beginning and continue with the next PDF file. This will take lots of time. These kinds of tasks may require a team of robots, or maybe it's a very huge task. You would need an army of robots maybe. This is all possible. We will see the mechanisms to share these works with the multiple robots in the later slides. But this is one example where you would need multiple robots. You don't want to wait. To finish all those tasks. You can also use branches with one robot, but maybe the CPU or memory would not be enough to do all of that. Maybe it will run slower at one point. So this is actually vertical scaling. You can increase the CPU number, the memory to run that in one robot, but you may also not do that. So you can do a horizontal scaling for doing this task. You can use many machines, and you can install robots to these machines, and you can share that task with multiple robots. One other case also may be high availability. We will cover an example in later slides. We have an example called web handler and processor robots. If web handler is very, very simple, and the processor robots does all the tasks, and you want it to run always, so maybe you can run two robots that are all processor robots, and if one fails, the other one will continue. That will be an example. So let's continue to queues. So we provide a mechanism to synchronize a task with multiple robots, and that's called queues. We have prepared an example for this. Let's jump to that. This is a very simple example. As I said, this robot is called the producer robot. So what it will do is it will extract a data from the PDF that is relatively faster than logging into a system and entering data and waiting the page loads time. But PDF parsing and extracting data is relatively faster. So one robot tasks may be just doing this, and it can extract the data from a PDF and can just put that data into a queue, and other robots running in another machine or maybe at the same machine, it can be, can get the next task, next item from a queue and process that. So we have a very simple example. We again have fake processing. We have a sleep here. We have a fake extract PDF data node here. You can actually use our PDF nodes here to extract text actually. Just to cover in this example, PDF data is unstructured data, so you won't get a clear JSON, structured JSON data. You will just get a text, and then you need to extract data inside that with regex. We use most of the time regex to get the data. Maybe you are looking for a code inside that PDF data, names, addresses, phone numbers. You can extract all those with regex. So what we have here is we just create a fake PDF data. What we do here is we create a data. We have a company field. This is Acme Corp. We add a parsed at. This is the timestamp. We have a fake document code. This is coming from this function that we get from Stack Overflow. This just generates a GoID. And then we have a random text that is parsed from our fake PDF extractor. So this is what it does. So you can think of that this data is extracted from a PDF, and later we add this data into a queue. So let's see this. We have a queue package. This is the default package that comes with the robot. You can add an item to a queue, get items from a queue. Maybe you can get 10 items or 20 items to process, or you can get one by one, get next item. You can delete an item from a queue. You can update the state that we will see here again, and wait item. I actually can't remember. It actually is waiting for an item with an item ID. No, the input name. It waits. Oh, it waits an item to be added into the queue. Actually, it can wait, for example, 300 seconds, and also there is a poll time here. It checks again and again. This is also maybe useful. So to use queues, you need to create one from the admin console. Here we have a queue screen. I created a queue previously. It is very easy to create. You just give it a name. and the description and press OK. So this is created. This is it just to create a queue. So I created a queue earlier and I did some tests. When you add an item to a queue, it sits here in the new state. And when you get an item from the queue with get next item, it comes here to in progress state. And when you update the status, you all have to manage this. This is just a mechanism to help you to create your flows. So you need to handle all the tasks because Robomotion or the queues can't know the status of your flow, what is successful, what is failed, what is abandoned. It can't know it. So there are some statuses, success, failed, and abandoned. So what we do here is this producer robot just adds the data into the queue. So let's run this. A random sleep and then add it to the queue. Now let's refresh this page and let's delete this another queue. We see a new item is added here. We can actually, to complicate things a little, we can use every 5 seconds, we can add another item to the queue and we can continue from here. Let's try this. After 5 seconds, it will inject. Now, this also has a random sleep here. And now when we refresh, we see new items are added. And let's open another flow. This is the consumer flow. .2 consumer robot. So in order to run this, we would need another robot. Let's connect another robot here. What this does is it actually gets the next item. I will also show the IS key. This is also important. I will explain that. We will get the next item from the queue and we will check if we can get an item. If there is no items in the queue, we will get a null item. So we check that and we go to continue. Let's connect this also. And this is again a fake process. And we update item state. We have processed the data. For example, we have entered the data into a CRM system or something somewhere. It is all done. And then we can use update item state here. The status we set successful. So let's run this. We will run this on the Gemini robot, the other robot. Let's also check the status. Gemini robot is running actually, but we didn't see the coloring. Yeah, we see this is all increasing. This is the producer robot is adding new items and also the consumer robot is all processing that. So you can run more robots here to process that data. You can run just one producer robot and run 5 consumer robots to finish those tasks faster. So also one last thing we need to cover is the at queues AES key. So the queue is actually a database in our site. So you may need to add some sensitive data to the queue mechanism, but we always care about the security and sensitivity of the data. So in order for us to not reach that data or see that data, we need an encryption mechanism. You need to create an AES key. You need to add an AES key into your vault for this. Let's open this vault. Now, vault security is you just have the key. We don't have the key. When you create a vault here, it will actually create a vault secret key on the client side. We don't get that. We don't. Let's see that actually here. Project Z create. This is the vault secret key. We don't save it. We don't see it. You need to save it in a secure place. And also you need to provide this to your robots. You can check that in the previous webinars, how to do that. So here we created a vault and we added an AES key. It is just adding it here. You can add it here. New item, AES key, you select one, you give it a name. You can regenerate and then save it. When you have an AES key, you need to, this is a mandatory requirement. This is not optional. You need to provide an AES key. So when robot runs, it actually encrypts that with your AES key and pushes to the queue. And also the consumer robot needs that. Yes, so we can continue. This is how queues works. So you can also use SQLite for synchronization. We use this a lot. There are it is very useful. SQLite is a very simple database. It is just a file, as you can see in the pros section. It's an embedded database. It is just a file. You can carry that database into anywhere. We actually did some projects, some scraping projects. Daily we create some DB files and then put that in some SFTP places for the clients to process them. They can get the file and query the data with SQL. It is very fast and easy to use. We have SQLite nodes. You don't need to install anything other than the package itself. It is just one click and you can use it in your flows. The cons is this can only be used in one machine. If you install multiple robots into one machine, it can be used, as we did see in the previous dynamic branching example. We used SQLite for synchronizing the data to see when the branch has finished. You can also use this in multiple robots running on one machine. Again, the same principles applies there. But if you run the robots on different machines, you can't use SQLite. That is the cons part. We will also see another usage of SQLite in the web handler example. There's of course an alternative to SQLite. This is using a shared database, but it is much more harder to install a database. You need to install it. You need to maintain it. It requires a dedicated machine. But the pros are it is most of the time runs on fast and dedicated servers. So multiple robots can use the shared database to synchronize. So this is also a way to do that. Most of the time we use SQLite. We don't use a database for synchronizing tests. Even for scraping, we use powerful machines. We use one robot or two or three robots at max, and we use multiple branches, and all we can handle with SQLite. So let's continue. So another usage of Robomotion is you can serve APIs with Robomotion. This is also powerful. As we saw in the previous slides, with HTTP in node, you can turn any website into an API. We turned CoinMarketCap into a web service. We just requested the data with a URL, and the robot gets the data from that page and returns that. return that. So there are two ways to serve APIs: synchronous serving or async serving. This is also an important topic. Most of the RPA tasks flows you design would require much time to be finished. For example, if it is a data extraction task, maybe you need to log into a site and click some date ranges, input some data, add some queries at that page, and then submit button and wait for the loading of that page, and you will get your data. And maybe that data has also multiple pages. You need to press the next button to get all the data. So this takes time. This can only be done with an RPA tool. That is great. But to serve that with a synchronous way, it is not possible. What synchronous means? It returning it immediately. For example, in the coin market cap example, we just open the browser, get the data and return it. It takes 2 or 3 seconds to finish. That is not very much. So it can be possible to do that. But some examples, as I said, may require lots of time, and so you need an async way to return the response. So let's see an example for these tools. So for synchronous serving, we used a very simple SQLite database. What we do here is we have an inject node, we have an initialize subflow. Here we again create the path. Our SQLite embedded database is called StatsDB. And we create the database. To make things easier, when I run this, it overwrites the database every time I run this. So we connect to it, and then we create a table. Let's see what the table looks like. It is a project and count. So let's think this is a project, a scraping project. You have 10 sites to be scraped, and you want to see the count of items you scraped from that project. So for that, we create a table like this. Let's see how it looks like. This is the stats database. Let's see how it looks like. The tool we use is dbeaver. This is an open source and free tool. We like it a lot. We use it. You can use it within database. So here we are using it with SQLite. This is the database. We have some example projects here. So this is X project, Y project, Z. So this is the scrape pages count. Maybe you can tell, and you see them here. Let's disconnect because it will create this again. We'll connect it later. And then we insert some data. You see the default data we saw was added from here. Let's change this, and let's change it to see the effects later. And then one thing is important here. So as you can see, HTTP in node is a trigger node. Actually, it is a web service. We create an endpoint called project count. This is a dynamic parameter, a path parameter. This is not static. You see 2 dots here. This is the syntax we use. If you put a 2 dot here before the word, this becomes a dynamic parameter. This is static. We will see how it is used. So this is the HTTP in node, and here we have a select node. You see this. We select the project name that we get from the path param. We will see how it works. So this is just a select query. But the important thing here is when we press play, there is no database connection here. And before that, there is no connection to be passed here. So for that, we use a global variable. We added a variable called con here. It's a string. And when we press play, the inject node also triggers. It goes to initialize database. What we have here is the name of the database, the path of the database. and then we have a create DB subflow. We again create the database with SQLite create the DB. We overwrite the database file if it exists. This won't be necessary and can't be in the production actually. This is just for example. We create it, we connect to it, and we create the table because we overwrite it. We created the table, and then we insert data here as we changed this before. Now, what I was going to show you that after the connect node call, the output of the connection descriptor actually, the connection ID is written into global variables here so that we can use it in here. So let's run this. So the inject started. We created the DB. Now let's check the DB here. Let's connect to it. You see the variables here. The updated values are here. Let's keep this open. And now we can call this. Let's run this. Curl HTTP localhost 1990. Now we can give the project name X, Y, Z. Let's look to X count. You see it returned 10. Let's see the Y count. It returned 16. The Z count, it is 37. You can run this again and again. You can run multiple requests at the same time. We can handle it. And for the DB, let's change the variable. Here, let's change to 99 and save it. We updated the DB. Now let's see the result at Y. You see the 99 here. So this is synchronous serving. What this means is that we have a web service here, and then we return the data immediately from here. So this is synchronous example. Let's continue with async example. So for the async example to work, we need to return to the service call immediately. What we do most of the time is we return a static result like, okay, it is true. We sometimes validate the request items. For example, this is a toy example. This is a simpler example, but most of the time we ask from our clients to send an ID, a unique ID with the request, and we add that to our database, and then you can check that the unique ID, maybe it is not unique, then you can return a false here, and you can add an error maybe here. This is possible. So what this example does is, you see it is branching here. These two branches are running in parallel. This branch continues from here, and it returns immediately to the caller. But we didn't return any data. We just return, okay, true. What this means is that we tell to the caller, everything is okay. I have got your request and I am processing it. We just say that to the caller, and maybe it is not validated. It is not right. There is something wrong with the request. We can return a false, and then with also a description. But here we forked here. There are multiple branches. The process branch actually processes the request. So again, there is a sleep here, fake process. And after everything is completed, done, we create an async response. What this means is that we can't return to the caller because we return to their request immediately. So we need somewhere to return the result. So for that, we ask from the client to open us a web service, to see the result of the request they sent us earlier, and to compare or to understand what result is associated with the request is we actually use unique IDs, and with the async response we always return the unique ID, so the client side knows that this is the response for a previous async request sent to the robot. So what can be done with this? Many things actually. For example, you can process or verify documents. You need to verify some PDF files in your onboarding processes. And for that, locally, we have these kinds of tasks. We have a PDF file generated from a government site, maybe your address or your ID information. You create that, you download that PDF from the government site, and you mail it or give it to the other side. So they check it, they go to the check page, verify page, they write the barcode at that PDF file to the page, and they see the same document there. They download it and compare the documents manually by hand. This is a manual task. So what can a robot do in this case? For example, they can put those PDFs into a folder, and you can just create a web service to your client and ask them to send you a request with a unique ID and the file path. Maybe it is a file system path or maybe a URL, it may be, to the PDF file. And for processing it, you just download the PDF and then read it with PDF notes here, and then open the browser, go to that page, compare the document, and if everything is okay, you can create your response. So this is also a very simple response. We set the ID. This is the unique ID we get from the caller, and we return the result with success. So as I said, we need a async API service, a webhook from the client side. So to run this example, we have to open another web service. So for this example, I found a simple Python script. This is an echo server. Let's run this here. This now listens to localhost 3000. We send the data. This is a post method. We send the data to that address. We don't need to fill anything else. We just fill the request here. This is an HTTP request node. So the input is the request. We prepare the request here. The ID comes from the caller that we will see now. Now let's run this flow. I hope it started. Now let's call it. I have saved a curl request for this. The 6th slides here. Let me paste it here. It is a little complicated, but this is a post request. We generate an ID. This is the UID gen is a bash command. It generates a UID. So I use that in the request. There is a static plate number. The operation rent. I don't know what this process does, but it is an example. So we have the process endpoint here. Let's see that. Yes, it is the process endpoint. Now let's run this. We return immediately. Okay, now it is processing. It returned the result here. You see the same ID. Of course, we can't see it here. The same ID returned, and we can also run this again. Let's see how it works. Yeah, you see the results are returning. We have projects like this, of course, a little complicated, but all the same principle. This is async web serving. You create an API and return the result in an async way. So let's continue. Now this is a little complicated example. We are actually going to serve again a web service, but we will process those requests from other robots. So we will have one robot to handle the web requests, and behind that we will have multiple robots to handle those requests. This may be an example for high availability. You may have two robots behind the web handler. Of course, there is always a single point of failure. Maybe you would need double robots for the web handler. You can run two web handlers, but to do that, you need two IP addresses and two ports to serve. So again, you would need a load balancer. This complicates things. You would need a load balancer, or maybe a very simple server code, or again a robot. It can be for client-side load balancing. For every request, maybe it can forward that request to one web handler or the other one. But in our cases, we actually run just one web handler robot, and we run multiple processor robots, because the web handler flows are very, very simple. It just gets the request and dumps it in a file system, a database, and then the processor actually is very, very complicated, so it can crash, it can happen, anything. So we run multiple robots for this task, and for this we run one robot actually. Let's see the example. So this is the web handler example. You see here again inject node, and we use SQLite in this example again. We create a database for the requests. This is taken from a real example, a real project from us, much simplified, of course, but the principles are same. We have a requests table. We insert every unique ID from the request itself as a JSON, and the created and updated columns are here. We keep a stage of the process. The processor robot may do multiple stages. It can validate and it can pass the stage, or some other stages. We use that. We also have try count. Think about this. For example, you have a government website behind that. You need to enter data there, but it fails. If after multiple tries, maybe it runs. This is possible. So the request caller may ask for a try count. The request type we keep in the database for multiple different kinds of requests we get. The status again, fail or success. The owner is actually the robot handled this process. We will see how this works. Let's see the database. Actually, the similar fields are here. We have just one table, the requests table. Let's delete these. Actually, it will be deleted when we start. Let's disconnect this. And at the bottom, we see the web handlers. There are multiple endpoints here. This is users add. For example, maybe you have a legacy CRM system and you want to integrate that legacy CRM system with your new system. In order to do that, you put an RPA robot there. In front of the CRM, robot uses the CRM application, but you send data from your new system to the robot. Robot will be a bridge for that. So you add a user with this service call. This is the processing method. I will show a nice way we use Discord Notify. We were using Slack actually, then we discovered Discord. We live in Discord, so we switched to Discord. This is very simple to use. Actually, I will show you this and how it works. So this is our Discord server. The Discord is actually free to use. You can create your Discord server and you can create a channel in your server. And after creating a channel, this is the channel I created. You just go to the integrations screen and you press this button, new webhook button. I create lots of that. So, and then you copy this webhook URL. That's it. You don't need to use any credentials. This URL has it inside. Let's see how it looks like. This is the generated URL for you. If you post anything here, it will go to that channel. We will see that. Let's delete this webhook. I have created before. This is the Flowbot. You can name it also. Now, let's see how it works. Here, we prepare the request to send that to that URL. It is very, very simple. It is just a request, a JSON request, content, and message. That's it. And you need to get your webhook Discord URL. We created a variable for that here. And again, because these are not connected, this uses the database, but there is no database connection here passed. So we use a global variable for that. We again initialize that here and we use from global variables. So let's check here. We will send a Discord request to every request comes from our caller. And then we actually do this also because you need to always check what the caller sends you and you need to check what you send a response to the caller. So to do that, we always log the coming request to the DB and the file system also. This may look complicated, but what it does is it creates a file system structure, year, month, day, and then we add the file, JSON file, and write the data coming from the request to that file. So this is the root path. This is the root path I use. Let's check that. Let's close this. And so there is a CRM folder here. There is a tree command. I should delete all this to clear things up. So this is empty now. This is the folder. We will create the folder structure. And we write the request and then we insert the request actually to the database. The dynamic fields are here. The body ID is the unique ID we will send to this web handler. And the log content is actually the JSON stringified request. So the request itself will be added here in the database. These are static changes to every web service. This is the add user. So I added comments here. We call it add user. It is stage 0. This can be anything you like. You can use anything here. Try count is 0. The owner is important because we are going to process this with multiple robots behind this web handler. There is a owner field here. We will see how it works later. So after inserting, we notified Discord that we had received a request. You can check that from your Discord, your mobile phone, and then we create a log file for the request, and then we insert it to the database, and then we prepare the response to the caller, as we see in the previous example. And we also log the response to a data file system. So that's it. We notify the Discord, we save it to the file, we write it to the database. Now let's run this. I have also prepared a curl line here. So this is the curl line. We will call users add method with curl. This is the unique ID I will use. These are not important, but let's now send this. You see it in the Discord. We have received a request. This is add user request received, the ID, the request received. Let's run another, for example. Let's see what is the delete. It is delete. You see we have this is also actually wrong. It failed because we couldn't insert it to the database. This example is not full enough. We didn't check the uniqueness of the request. Let's run this. It will not return because the flow has failed because we didn't check this. Let's see the error code here. It can't insert it to the database because unique constraint failed. You have to handle this, of course. You have to return a false response to the caller, but let's run this again. And we won't make the same mistake again. Now let's, for example, run this with add. We will again see the request. Now the delete request. Let's change the unique ID. Now we have the delete request. This also we use coloring. For example, if you have started a project, you have many endpoints to complete. We do in this way. The red one is not implemented or not finished yet, and also you can return false and error update a user is not implemented yet. We don't insert it to the database. Let's see that also. Let's change the ID. You see, we see it in the Discord, but we returned false. Now, the fun part, we will open the processor flow. Not this one. This is 7.2. Okay. Now, when this starts, it again initialize the database. It connects to the database, the SQLite database, get a request. This is also important. We have added some global system variables in the last versions. We get the robot ID like this. This robot, any robot, we don't know what we will use right now, but you can get the robot ID. The robot ID is actually here. This is the robot ID. You can also use the robot name if you like. We will use this in the owner field. Let's close this and open the handler database that we are using here. So this is the owner field. You see the two requests are written here. The first one of them is add, one of them is delete. The update not implemented is not here. This is the request types. Now the processor robots, what they will do is they will try to get one row from this database that has an owner field of empty. And after getting that, they will try to set their name to this owner field. And then again, they will try to get this field with their name. So let's see that how it works. So we use a robot ID here. Sometimes the branches crashes. For example, you may have some unhandled exception. So you may have left the DB with the robot ID, and no other robot can process that because only the owner of that robot. But if the robot crashes, it won't be handled. So we also clear that. When the robot runs, it clears previously owned rows by their name. You can, of course, use another flow for cleaning maybe, but we do that. we just update it to the empty that has the robot's own ID. And then we try to get status 0. This means non-processed. We created all this, we designed this, we used the status column for the non-processed items, and we are looking for a row with no owner, and we will set it to our own. So the robot, when it runs, it will get this request and set, I am the owner of this row, I will process this. And then after that, it gets it actually here with status 0, limit 1, owner 1. And then we set the task. This is the select query will return just one row, but we put it in a message task. If there is no item returned for this robot, then we set it to null. And we get the request. Now we check the task exists. If there is no item left in the database, then it will return null, or it will be full. Then we can process it. We can update the status. Now we set the owner because we have finished with it. Maybe you cannot set also to this. Maybe later you want to check which robot did that. We just cleared it. But we changed the status to 1 because we have finished with it. Also, we find that row with the request ID. And we again send the notify request to the Discord that we have finished it successfully. We get the type from the database. We know that if it is 1, it is an add user. If it is 2, it is a delete user. This is just to create a nice message to the Discord. Again, we send the message to the Discord, and then we return. So that's it, how we can process it. And we sleep and go to next and get another request, and then again and again. If there is no request left, then we will see this no work debug. If you put stop here, that is also fine. But for this example, we will loop here. If you put a stop here, for example, maybe you can schedule this process and you can run it every 5 minutes to check if anything new in the database. Now it is time to run this. To do that, we have to connect another robot. Let's see if we have one. What is the robot running the other flow? It has to be, let's see, this one. It says it is running. Maybe this is the other one. Okay. Now it starts. It gets the request from the database, and you see it has finished successfully this process, and it continues. It will process the other request again, and then let's check this. You see the status are all 1-1, and it is finished now. Now let's run this non-stop. So again, we just need to, maybe we can add another robot for fun. This is the Gemini robot. Let's run the Silver Centurion. Now it is also running. And then run this flow on the Silver Centurion. It is the processor robot again. It will start and there is no work. It will sleep, check again. They are all running now, multiple robots. And this is the handler, web handler. The backend are, now let's send multiple requests here. Let's send add. We have seen the request. Let's send 16. Let's send 17. Let's put an end there to add more. If I can add faster. Okay, now let's check what happened. Now you see I have sent multiple requests. We have received all those requests with the web handler, and some of them are processed by the Silver Centurion, and one of them, some of them are processed with the Gemini robot. So this is a nice way to handle a request with multiple robots. One web handler robot is just putting data into the database and sending a notify to the Discord, and the other processing robots are doing the job behind. You can schedule this, or what we do, we schedule these tasks and we run this always, and if crashes, if something happens, it will be scheduled to run again, so it will continue from where it's left. So let's stop these and continue. Let's stop this. So our last topic is maybe helpful. So dynamic content serving. This is also possible. Where can this be used? For example, if you have a scraping robot project and you need to check what is the result, what is the last result, what is the status of that robot, maybe you can create a very simple web page to show that, and you can serve that from within your flow. You don't need another robot for this. You can use the same robot because you can use multiple branches like this. You can just put a simple subflow here for your status check page. So let's quickly see these examples, and let's wrap up this webinar. Now, this is very simple. We use HTTP template node here. What it does is, it actually, you can put an HTML source code here, and you can replace the data here that comes from the flow, so you can create a dynamic page. So let's run this and let's see how it works. This is X, this is Y. Let's change this to 9983. Save, and let's run this. We just create the template and write it to a file called generated HTML. Let's run this. Okay, it is finished. Now let's see the file. This is generated HTML. You see the generated HTML is like this. This is what we gave to create this HTML. So how can this be used? Let's jump to the other example. 8.2 self-serving HTTP template. So here what we use is, we again use the previously used status database. Here it will create it again, so I will just disconnect these and check that later. Disconnect these. Disconnect. Okay, now we will use the stats database. We create the database from the start. We input the data here. Examples. This can be the project page you are scraping, and this is the pages scraped. The status, you want to see the status all the time. Maybe you open a web page in your browser and you refresh all the time to see the results. Now, after this, we have a web service here, HTTP in node. We check. We use a get method. We use an endpoint stats, and then we get the results from the stats table, and then we process the results. What we do here is, we just put the message object fields, message.x, message.y, message.z. We create those, and then again we used here, and then we return the result. But this is important. When we are returning the result, we use text HTML and charset UTF-8. We are not using content type JSON. If we use that, you will see a JSON object. What we want to see is the generated HTML page. So let's run this. Now the database is created. Let's open that. This is the stats page. This is the stats table. You see the results here. Now let's open this in our browser. This was the static file. Let's open another, and we called it stats. When you run this, you see the pages generated, and you return it into this web page. Now let's change the database, because you are always updating it from your flow. Save this, and let's refresh this page. You see the results are changed. This is useful. What you can do is you can just put this into your subflow and put that somewhere in your scraping flow, and you can always check your status. One nice way is, oh, this is ugly. This is ugly. You can just use some single page CSS examples. This is the same example. I share the resource here. You can go to this page. There are many one-page HTML files here. I like this one. So this is like this. When you download this, you will just see one index.html file here. When you open it, you see it's like this. I just take that HTML file and put it here, and changed some, removed most of the unused ones, and I just put my X, Y, and Z here. Now let's serve this. Now let's run this again. You see it is updated, and now it looks very nice. So this is also a way to check your status. Discord is very nice. Maybe you may need a status page like this in your flow. So that's it for today's webinar. If you have any questions, please ask. We can now continue with the questions. Let me check the questions here. Any questions? Okay. Then thanks for joining us today, and see you next time in our next webinar. As I said in the beginning, we will share this recording in our webinar page, and also we will share the slides with you. All the examples here you can reach. They are shared flows. You can reach to them and play with them. Thanks a lot for joining us. Thank you, and see you again in our next webinars. Good night.